The thunderous roar of blast furnaces melting iron at temperatures European smiths wouldn't reach for 1,000 years. The rhythmic clang of water-powered trip hammers mass-producing steel while Western blacksmiths still hammered by hand. The terrifying hiss of gunpowder weapons obliterating castle walls that were designed to withstand medieval siege engines. This is not some alternate history fantasy. This is the brutal reality of Chinese technological supremacy, a civilization that achieved proto-industrial innovation centuries before Europe began the Industrial Revolution. We have all heard stories of medieval progress, but what ancient Chinese engineers accomplished reveals something else entirely. While Europe was struggling with basic metallurgy, China was operating automated factories, precision instruments, and chemical weapons that wouldn't appear in the West until the Renaissance. You think the Industrial Revolution started in 18th century Britain? Ancient Chinese workshops would make Manchester textile mills look like primitive cottage industries. Behind this image of medieval European advancement lay a technological gap so vast that it literally shaped the course of world history. This wasn't random innovation. It was systematic engineering superiority, a coordinated approach to solving problems that created technologies so advanced they seemed like magic to European observers who encountered them centuries later. Today we're diving into 15 Chinese technologies that were so far ahead of their time that medieval Europe couldn't even understand how they worked, let alone replicate them. This is the story of the civilization that built the future while the West was still living in the technological past. This is the story of the first technological revolution. But here's what most people don't realize about ancient Chinese blacksmithing. They weren't hammering individual pieces of iron. They were operating blast furnaces that could melt iron completely and cast it into standardized molds using techniques Europe wouldn't master until the 14th century. Picture the systematic superiority. Chinese metallurgists achieving temperatures over 1,300 degrees Celsius in the 4th century BCE, while European smiths were still struggling with bog iron that barely reached red heat. The blast furnace wasn't just a bigger fire. It was precision engineering with water-powered bellows, controlled air injection, and sophisticated temperature management that enabled mass production of cast iron tools, weapons, and cookware. Archaeological evidence reveals Chinese casting operations producing thousands of identical items using assembly line techniques that prefigured modern manufacturing by over 2 millennia. But here's where it gets insane. Chinese blast furnaces could operate continuously for months, producing tons of high-quality iron while European smiths were still making individual pieces that took days to complete. Get this, while European blacksmiths were swinging hammers by hand, Chinese engineers had created automated stamping presses powered by flowing water that could work around the clock without human fatigue. Imagine the mechanical genius. Water wheels using cams and levers to lift massive hammers weighing hundreds of pounds, then drop them with devastating force onto whatever needed processing. This was the world's first industrial automation. Mechanical power replacing human labor with relentless precision that could crush grain, process ore, and shape metal with consistency no human could match. Archaeological evidence from Han Dynasty sites reveals trip hammer installations with gear systems and power transmission mechanisms that wouldn't appear in Europe until the Industrial Revolution. The sound was like industrial thunder, the birth of mechanized production that announced China's entry into the machine age, while Europe remained in the age of hand tools. But it gets worse. Chinese engineers were drilling boreholes over 1,000 meters deep to extract brine and natural gas using percussion techniques that prefigured the entire modern petroleum industry. Picture the technological sophistication. Bamboo cables supporting drilling equipment at extreme depths, derricks lifting tons of machinery, and gas capture systems channeling natural gas through bamboo pipelines to fuel industrial operations. This wasn't just mining. It was advanced geology applied to systematic resource extraction. Chinese engineers understood subsurface formations well enough to predict where valuable deposits could be found. The Sichuan salt wells represented an integrated industrial system, where natural gas powered the evaporation processes that refined salt from brine. Vertical integration that wouldn't appear in European industry until the 19th century. Modern petroleum engineers studying these ancient sites describe them as the most sophisticated pre-industrial drilling operations in human history. Here's where it gets insane. Susong's astronomical clock tower wasn't just a timepiece, it was a 40-foot mechanical computer that demonstrated Chinese mastery of precision engineering centuries before Europe developed similar technology. Imagine the mechanical complexity. Hundreds of bronze gears working in perfect synchronization, a water-powered escapement mechanism capable of converting continuous water power into precise regulated motion. Centuries before Europe's mechanical clocks and automated figures announcing the hours. This was the world's first programmable machine that could perform complex calculations, display multiple types of information, and operate autonomously. Mechanical capabilities that wouldn't appear in European technology until the Renaissance. But here's what's truly terrifying. The escapement mechanism was the critical innovation that made all later mechanical clocks possible. Without this Song Dynasty invention, European clockmaking couldn't have existed. Archaeological analysis reveals gear ratios calculated to astronomical precision and bronze casting techniques achieving tolerances measured in fractions of millimeters. But the real revolution was in information technology. Chinese paper manufacturing created the world's first mass media industry and enabled bureaucratic systems that governed the largest empire in human history. Picture the industrial chemistry. Plant fibers broken down through chemical processes, suspended in water, then formed into thin sheets using screens and presses. Systematic manufacturing applied to information storage. This wasn't just a writing surface. It was the foundation of centralized bureaucracy that could administer hundreds of millions of people across vast distances using standardized documentation. Paper production required understanding of fiber chemistry, hydraulic pressing, and quality control that created a standardized product suitable for mass distribution. Archaeological evidence reveals paper mills with water-powered machinery and chemical processing facilities, reportedly producing thousands of sheets per day. Industrial-scale information technology manufacturing. The real genius was understanding that information itself could be industrialized, enabling mass education and administrative efficiency that gave China decisive advantages over less organized civilizations. Get this. While European monks were copying books by hand, Chinese printers were operating movable type systems that could produce thousands of identical copies using techniques that prefigured modern publishing. Imagine the systematic precision. Individual characters cast in bronze or carved from wood, arranged in frames to create complete pages, then used to print multiple copies before being rearranged for different texts. This was the world's first mass media industry, enabling rapid distribution of standardized information across the entire Chinese empire. A communication revolution that gave China decisive advantages in education and administration. Movable type printing enabled the creation of standardized knowledge that could be distributed to government officials, military commanders, and technical specialists across thousands of miles. Archaeological evidence reveals printing workshops with sophisticated type storage systems and quality control processes, ensuring consistent reproduction across multiple copies. But here's where it gets insane. Chinese printing wasn't just about books. It included maps, technical manuals, and administrative documents that created the information infrastructure of the world's most advanced civilization. But here's what's truly shocking. Chinese financial engineers had invented fiat money and central banking systems centuries before Europe understood basic principles of credit and monetary policy. Picture the conceptual breakthrough, understanding that value could be represented by symbols rather than precious metals, creating government-backed currency deriving worth from institutional authority rather than intrinsic material value. The Jiaozi wasn't just convenient. It was advanced financial technology, enabling complex economic transactions across vast distances without the logistical nightmare of transporting tons of metal coinage. Paper currency required sophisticated anti-counterfeiting technology, including special papers, complex printing techniques, and government authentication systems prefiguring modern security features. Archaeological evidence reveals currency production facilities with controlled access and quality control systems maintaining monetary system integrity across the entire empire. The real genius was understanding that money itself was information technology, a standardized system for storing and transmitting economic value that could be industrialized like any other manufacturing process. What's truly terrifying is how Chinese navigational technology transformed global commerce. The magnetic compass wasn't just a direction-finding tool. It was precision navigation technology, enabling systematic exploration and trade across vast oceanic distances. Picture the scientific breakthrough. Understanding that magnetized iron would align with Earth's magnetic field, creating precision instruments maintaining accuracy despite ship motion. This was scientific navigation, replacing guesswork with systematic position finding. Chinese navigators could determine location and course with precision that wouldn't be matched by European sailors until the Renaissance. The compass enabled Chinese treasure fleets, massive naval expeditions with hundreds of ships carrying thousands of personnel across the Indian Ocean to establish trade relationships and demonstrate technological superiority. Archaeological evidence from shipwrecks reveals compass systems integrated with sophisticated navigational instruments and mathematical calculation tools, enabling precision navigation across thousands of miles of open ocean. But here's where it gets insane. Chinese navigational technology was so advanced that European explorers used Chinese-made compasses and Chinese navigational techniques during the Age of Exploration. But the real game-changer was chemical warfare. Chinese military engineers had weaponized explosive chemistry centuries before European armies understood basic principles of gunpowder combustion. Imagine the systematic experimentation. Understanding that saltpeter, sulfur, and charcoal could be combined in specific ratios to create controlled explosions, developing manufacturing techniques, producing consistent explosive compounds. This wasn't just a bigger weapon. It was industrial chemistry applied to military technology. Chinese weapons manufacturers could mass-produce gunpowder using standardized processes, ensuring consistent performance. But here's what's truly shocking. Chinese gunpowder weapons included rocket artillery, explosive grenades, flamethrowers, and primitive firearms, giving Chinese armies overwhelming advantages against enemies using traditional weapons. Archaeological evidence reveals gunpowder manufacturing facilities with sophisticated safety systems and production techniques that could supply massive military campaigns with reliable explosive weapons. The real genius was understanding that chemical energy could be harnessed and controlled for military applications. Systematic weaponization of scientific principles, transforming warfare itself. Chinese metallurgists weren't just making better iron. They were creating steel alloys with controlled carbon content using techniques that wouldn't appear in European metallurgy until the industrial age. Picture the chemical mastery. Understanding that different carbon concentrations created different material properties, developing systematic techniques for controlling steel composition through precise temperature and timing management. Chinese steel production included pattern-welded blades with thousands of layers, each precisely controlled for carbon content and grain structure. Composite materials engineering that created weapons superior to anything produced in medieval Europe. But here's what's truly terrifying. Chinese metallurgists could produce steel with properties rivaling modern alloys using pre-industrial techniques that required understanding of chemistry centuries before it became a formal science. Archaeological analysis reveals steel samples with carbon gradients transitioning smoothly across microscopic distances. Precision that required metallurgical knowledge that wouldn't be formalized until the 20th century. The sound was like alchemy becoming science. the systematic transformation of base metals into superior materials through controlled chemical processes. Get this. Chinese scientists had created earthquake detection instruments that could sense seismic activity from hundreds of miles away using mechanical amplification systems that prefigured modern seismology. Imagine the scientific sophistication, understanding that ground vibrations could be mechanically amplified and directionally analyzed, creating instruments that could detect and locate distant earthquakes. According to historical accounts, Zheng Heng's seismoscope wasn't just a curiosity. It was precision scientific instrumentation, demonstrating Chinese mastery of mechanical engineering applied to natural phenomena detection. The device used pendulum mechanisms and mechanical linkages to convert tiny ground movements into visible indicators, signal amplification technology that wouldn't appear in European science until the Renaissance. But here's where it gets insane. The seismoscope could not only detect earthquakes, but indicate their direction, enabling rapid response to natural disasters across the vast Chinese empire. Archaeological evidence suggests the instrument was part of a systematic approach to natural disaster management that included early warning systems and coordinated relief efforts. But here's what's truly shocking about Chinese naval technology. They had solved the fundamental problem of ship survival using watertight compartment systems that made their vessels virtually unsinkable. Picture the engineering genius. Ships divided into multiple sealed compartments so that damage to one section wouldn't sink the entire vessel. Safety engineering that wouldn't appear in European shipbuilding until the 19th century. Chinese junks could survive catastrophic hull damage that would sink European vessels because the watertight bulkhead system contained flooding to damage sections while keeping the rest of the ship operational. This wasn't just better shipbuilding. It was systematic safety engineering that enabled Chinese vessels to undertake oceanic voyages that would be suicidal in European ships. Archaeological evidence from shipwrecks reveals sophisticated bulkhead construction with multiple sealing systems and drainage mechanisms that could handle severe structural damage. The technology enabled Chinese treasure fleets to cross the Indian Ocean with confidence, knowing their ships could survive storms and accidents that would destroy conventional vessels. Here's where it gets insane. Chinese agricultural technology wasn't just better farming. It was systematic food production using techniques that enabled China to support the world's largest population for over a millennium. The iron moldboard plow could cut, lift, and turn tough soils with efficiency that wouldn't be matched in European agriculture until the 18th century. Multi-tube seed drills planted seeds at perfect depth and spacing, eliminating the catastrophic waste of broadcast seeding. Precision agriculture that maximized crop yields through scientific planting techniques. But here's what's truly terrifying. Chinese agricultural systems could support population densities that would cause famine in Europe, creating the demographic foundation for China's technological and military superiority. Archaeological evidence reveals irrigation systems, terracing projects, and soil management techniques that sustained intensive agriculture across millions of acres for thousands of years. Get this, Chinese engineers were building suspension bridges using iron chains and sophisticated structural analysis, while European bridge builders were still limited to stone arches and wooden spans. Picture the engineering mastery. Understanding that flexible suspension systems could span greater distances than rigid structures, creating bridges that could handle both static loads and dynamic forces. Chinese suspension bridges used wrought iron chains with tensile strength calculations that wouldn't be formalized in European engineering until the industrial age. But here's where it gets insane. These bridges could span gorges and rivers that were impossible to cross using European bridge building techniques, enabling transportation networks across terrain that would isolate European communities. Archaeological evidence reveals bridge construction techniques using mathematical analysis of load distribution and structural dynamics that prefigured modern engineering principles. But the ultimate demonstration of Chinese technological superiority was porcelain, a material so advanced that Europeans called it white gold. and spent centuries trying to discover the manufacturing secrets. Imagine the chemical mastery, understanding that specific clay compositions fired at precise temperatures could create ceramic materials with strength, translucency, and beauty that seemed impossible to European craftsmen. Chinese porcelain required advanced kiln technology that allowed for precise temperature control, precision manufacturing that created materials superior to anything produced in medieval Europe. But here's what's truly shocking. Porcelain manufacturing involved understanding of chemistry, materials science, and precision manufacturing that wouldn't be matched in European ceramics until the 18th century. The technology created products so superior that they became the foundation of global trade networks, with European merchants paying enormous sums for Chinese ceramics they couldn't replicate. These 15 technologies represent more than just superior innovation. They showcase a systematic approach to engineering that was centuries ahead of its time, creating a technological civilization that dominated the medieval world through scientific understanding and manufacturing capability. While medieval Europe was struggling with basic metallurgy and agriculture, China was operating automated factories, precision instruments, and chemical weapons that wouldn't appear in the West until the Renaissance or later. The Chinese approach was systematic, scientific, and absolutely revolutionary in its implications. They had discovered that human productivity could be multiplied through mechanical innovation, that natural forces could be harnessed for industrial purposes, and that scientific understanding could create technologies that seemed magical to less advanced civilizations. So the next time you hear about medieval progress or European innovation, remember that China had already built the technological foundation of the modern world, while the West was still learning to make decent steel. These weren't just better tools, they were the building blocks of modernity, created by engineers who understood that systematic innovation could transform the very nature of human civilization. The medieval West couldn't match these technologies because they represented a completely different approach to understanding and manipulating the natural world. An approach that made China the most advanced civilization on Earth for over 1,000 years.